Okay, for the first problem, it is the rigid body system. Okay, is composed of the link AB, link BC, and also the column C. The column C can move horizontally, okay, along the track. Okay, we would like to find the angular velocity of lot BC, angular acceleration of lot BC, and velocity vector of point B. Okay. For this problem, it's maybe more complicated than the group activity that we have done on Wednesday because we have to solve for angular acceleration also. But actually, the procedure is just the same, but we have to use the different formula. That is the formula for the acceleration that is maybe have more term than the velocity. Okay, so we may just starting with, okay, from this problem. I hint to you a little bit, okay, by we starting with set up the coordinate system and define the positive sign convention here. The positive sign convention, okay, we have to set up according to the right hand rule. Okay, so then for this case, we set up the positive sign convention over here. Okay, and then we have to draw the additional figure to identify the problem. Okay, each motion should be defined follows the positive sign convention. Okay, this is very important in my opinion when we solve for the dynamics problem in both kinematics and kinetics. Okay, it's very important to consistent use the positive sign convention. Okay, and after we have this, okay, we draw the picture like that, like this. Okay, and for this case, we you will see that we set up omega, that is the rotation, that is maybe about the c-axis according to the right hand rule. Okay, so omega AB, alpha AB, omega BC, and alpha BC is we because we don't know now what it should be. Okay, so then we set up it to be at the directions of the positive direction. Okay, first. And for velocity of B, okay, so for this case, we may describe type of motion of each component first. That is the motion of the column C is what? For this case, the motion of the column C is what?
Rectilinear translation.
Okay, it is the rectilinear translation. That's correct. Okay, it's rectilinear. This is a rectilinear translation. Okay, because the column C moving along the track, that is just move to the right and to the left, just the whole line. So then it is a straight line, and it is the moving just only the translation. It has no motion now. Okay, so it's become the translation, and because the track, the part is linear, so then we add the rectilinear in front of translation to define that, to more specify for this case, that is the rectilinear translation. And for link BC is what? Link BC.
General plane.
Yeah, it is a general plane motion because for link BC, we can see that link BC has translation and it has the rotation also. Okay, so it's combination for both type of motion, that is composed of translation and is composed of translation and rotation. Okay, so then it's become the general plane motion. Okay, for this case. And for the last one, it is link AB. Link AB is what?
Rotation about fixed axis.
Yes, yes, very good. Thank you. This is a rotation about a fixed axis. Okay, so the axis that we mentioned to for this case for the link AB is the point A. That is the axis that's passed through point A, the axis C. Okay, for that case. So according to this, when we define that AB is the rotation about a fixed axis. So then point B, we can predict that VB has we can predict the velocity direction of VB. Okay, we assume that the direction of VB should be in the has the direction should be consistent with the positive sign convention, consistent with the rotation in positive sign convention. So then if the link AB rotate in positive sign convention of omega, so then we may predict that velocity of point B should be moving in this direction, that it should be moved to the left and downward. Okay, it should be like this, but it is in vector. So after we have the picture like this, so then we may starting with consider the link AB first. Okay, so for consider the link AB, we starting with set up the coordinate at point A, that is the fixed coordinate, right? Okay, and for this case, it's because it is a rotation about a fixed axis. So then velocity vector is easy to determine by omega AB cross product with RB sub A. That is the vector of point B, the position vector of point B with respect to point A. Okay, so for this case, if we consider omega AB, okay, in vector, it is in direction in C direction, right? It should be in C direction, that it should be in this case. This is omega AB here. So then we have to write it in vector form, that it should be like this. This should be omega AB, right? Okay, and for the RB sub A, that is the position vector of point B with respect to point A. Since we set up point A as the reference, so then RB sub A is a measure of point B from point A. And we know that the arm AB is equal to 0.6, and the angle now is equal to 60 degrees. So what is the position vector RB sub A should be? Is equal to what? Okay, so for this case, we found out when we projection it into x-axis, okay, it's become, we know that this should be 0.6 cosine 60 degree, right? Okay, but it go to the left, so it should be minus 0.6, okay, cosine 60 degree, okay, for this case. And for y direction, is what? This is this component. When we breaking into the projection into y component, we have 0.6 sine 60 degree, right? Okay, and this is goes up, so then it should be the positive one. This becomes 0.6 sine, okay, but I have to add sine also, plus 0.6 sine 60 degree. Okay, and after that, what's happened? Okay, so This is a scalar quantity. This is also the scalar quantity. It is a scalar quantity, and with represent with the vector quantity here. That is a unit vector. Okay, we cross product with k cross I. Okay, k cross I here. K cross I become positive j. Okay, and omega AB times minus 0.6 cosine 60. Okay, cosine 60 is a half, right? So then, for this case, we found that is become minus 0.3 omega AB, right? And for last term, okay, we found out k cross j is what? K cross j is become minus I. Okay, so this should be plus, but omega AB times plus 0.6 sine 60. Okay, it's maybe like this, 0.52 omega AB, right? Okay, and it's negative and it's positive, so then it's become negative, right? Minus. Okay, this is I component, it should be here, and it's minus 0.52 omega AB. And for j component, it's become minus 0.3 omega AB. Okay, now we have velocity vector for point B. Okay, is have omega AB as the unknown. Okay, we leave it first for this step. We may leave it because it is the unknown now. But if we know that, if we know VB, okay, in the vector form, we can solve for omega AB at this step. But at this moment, we don't know. Okay, so then we leave it. So we go to next step. Okay, to next step, we found out we consider the link BC now. We consider link BC. That is the general plane motion. But at this moment, we already know VB from the previous step. We know VB. Okay, so we move to find the velocity of VC. Okay, with respect to VB. Okay, so then we have VC equal to VB plus omega BC cos RC sub B. Okay, so for VB, we already know that from the previous step. We have it is equal to minus 0.52 omega AB and minus 0.3 omega AB. Okay, and for this we have omega BC. In the same manner, we may set up is to be the positive sign convention that is equal to omega BCK. It's cross product with what? With the vector, the relative vector of point C, position vector of point C with respect to point B. Okay, that's now that we set up. Mean that we have to set up axis at point B now. Okay, and we know the length of length BC is equal to 0.4. So and the angle for this length is equal to 45 degrees. So then for I direction is equal to 0.4 cosine 45. Okay, and for y direction it's become 0.4 sine 45. It's both are positive. Okay, so according to this, we may solving for this equation. Okay, solving for this step. Okay, we have minus 0.52 omega AB first. That is this is the first term. Okay, for the next term we have k cross j. Okay, k cross j is become minus I. Okay, and for this term it's become minus 0.4 times sine 45. What is it? 0.4 times sine 45. What is it? It's become 0.28. Okay, 283. That's all right. Thank you very much. Okay, so then we have 0.283 now here. And so we have the term of minus 0.283 omega BC here. Okay, and for the J component, we already have minus 0.3 omega AB. Okay, and for J, we K cross I become J, that is plus, okay, 0.283 omega BC. Okay, but so for this case, we already find out velocity of point C, velocity of column C should be here, should be equal to this vector. Okay, but from the problem, we know that we see is the rectilinear translation. Rectilinear translation is can move just a little to the left and to the right, and the problem gives us that point C moving to the right with 3 meters per second. So it's moved to the right. So then it means that for the positive side direction to the right, it means that it is a positive one, right? So then we see is equal to 3i. Okay. So after that, we compare these two vectors and solve the equation in order to find two unknown of omega AB and omega BC. So according to this, by equating vector, that is, we know that VC is equal to 3i, and also we know that VC equal to this vector. We we decompose these two vectors by setup. The components of I should be equivalent, and component of J should be equivalent also. We get two equations as follow. That is, for the first one, for I component, this become minus 0.52 omega AB minus 0.283 omega BC equal to what? Is equal to 3. Okay. For J component is equal to minus 0.3 omega AB plus 0.283 omega BC. That equal to the left hand side. That is, we found out we see it just has just only one component in I. So for in J it becomes 0. Okay, so we have two equations now with two unknown, omega AB and BC. Okay, so for this case, you may solve this equation by yourself. That is the linear equation. That is very easy to solve. Okay, so then after we solve the equation, we found out omega AB is equal to minus 3.659 radian per second. Okay, and also omega BC is equal to minus 3.878 radian per second. But that means for negative sign, okay, negative sign mean that
Its direction is clockwise.
Yeah, means the directions of omega AB and omega BC are clockwise. Okay, that's like this. It's clockwise. Okay, it makes sense, right? When C moving to the right, Okay, so then link BC and AB should be rotated clockwise. Okay, this makes sense. So consequently, the velocity vector of point B is become what? Okay, we substitute the value into the velocity vector that we already know. Velocity vector of point B, not point C. Point B, we back to this. Okay, that is equal to what? It's equal to minus 0.52 and minus 3.659. Okay, it's minus 0.3 minus 3.878. Okay, that's we found that it's become 1.903 here, and it should be plus 1.163. Okay, and the angle here of the is we would like to find the direction, and is equal to arc10 what? Arc10, the vertical component, that is 1.163 divided by 1.903, that is equal to what? It's become 31.4 degree. Let's finish for this step. That's we found the velocity vector already. Okay, and next we will moving to find the acceleration vector of point B. Okay, to find the acceleration vector, okay, we have to consider the formula for relative acceleration. Okay, so for this case, because link AB is the rotation about a fixed axis, is the rotation about a fixed axis. So then it's composed of the acceleration is composed of two components. That is the first one is the tangential component, and the second one is the normal component. And do not confuse about the cross product and the multiplication product. Okay, because this term, okay, is become scalar already if you review the textbook. Okay, and after we derive the acceleration, that is actually is come from the first derivative to the velocity, and we also have the term that is we have this term that is equal to omega AB. That is, this term is the scalar term time to the RB sub A vector. This is a vector. Okay, but for the first term, that is equal to alpha AB. Alpha AB is the angular acceleration vector. Cross product, this is a cross product with RB sub A, that is a position vector of point B with respect to point A. Okay, so according to this, we starting with when substitute each value into the formula here, and we found out the first term alpha AB vector is equal to alpha AB here, cross product with RB sub A, that is what? That is the position vector of point B with respect to point A. So then we have to set up axis at point A first. And for this case, we found out the arm OA. Okay, arm OA is we already find, right? Okay, for the first one, that is actually we already done here. RB sub. Okay, sorry. This step. we already done. That is equal to 0 minus 0.3 and plus 0.52. Okay, so to this step is equal to minus 0.3 and 0.52. That is the positive. Okay, minus what? Minus omega AB, that is a scalar term. And now we already determine omega AB. Omega AB is what? Omega AB is minus 3.659. Okay, so it's equal to minus 3.659 and square. Okay, and the position vector of point B with respect to point A should be the same, that is minus 0.3 and plus 0.52. Okay, after we manipulate this equation, okay, by do the cross product and add up each term, so we found out a acceleration of point B should be 4.02 minus 0.52 alpha AB. Okay, this is just the first term for I components. And for J component, it's become minus 6.96. Okay, minus 0.3 alpha AB. Okay, so for this step, okay, you will see that I just conclude the solution to you, but I recommend you to do it by yourself in order to find out why it's come from here. Okay, and now we already have AB, accelerations of point B, vector of acceleration of point B here, and we have the unknown alpha AB. Okay, same step like the velocity. Okay, we move to consider lot BC, that link BC. This is a general plane motion. Okay, so the acceleration equation, it is composed of acceleration of point B plus alpha BC cross product with the RC sub B. Okay, and minus omega BC square cross product with RC sub B. Okay, remind yourself that this is the scalar term, but another one is the vector. So you see that in for to this step, I mentioned to you many times that we have to write the correct notation also in order to reduce our confusion. Okay, some students are confused about this term. They think that this term is a vector also, and then they do this operator to be the dot product. That is maybe do not correct. Okay, and also for omega BC, they confuse about the quantity, and so then they confuse about the direction also. So that is why we have to understand for the case that when we use the formula to solve. Okay, so according to this, we have to substitute each value into this step. Okay, for AB, okay, AB we know already, right? AB, okay, AB is 4.02 minus 0.52 alpha AB. Okay, and this should be minus 6.96 minus 0.3 alpha AB. Okay, and for next step, we have alpha here. It should be alpha BC. Okay, and for RC sub B, we already find for the previous one, it's equal to 0.283. Okay, plus 0.283. And we're moving to this term, the last one, that is equal to minus omega BC squared. Omega BC now we already know, right? Omega BC is minus 3.8. Okay, so it's become minus 3.8. 78. Okay, but square. Okay, multiply with RC sub B. RC sub B here is equal to what? Is equal to 0.283 plus 0.283 now. According to this, we rearrange this equation again and working out with the vector cross product. Okay, and we rearrange the term. We obtain this one, that is equal to minus 0.236 minus 0.52 alpha AB. Okay, minus 0.283 alpha BC. Okay, plus J term, for the J term is become minus 11.216 and minus 0.3 alpha AB plus 0.283 alpha BC. Okay, and for the problem give us that AC is become minus 5i. Okay, so then we equating this equation, we obtain first one, that is minus 0.236. Okay, minus 0.52 alpha AB and minus 0.283 alpha BC. It's become minus 5. Okay, and the second one, we consider the J component, that is 11.216 negative sign. Okay, minus 0.3 alpha AB. Okay, and the last term is 0.283 alpha BC. It's become 0. Okay, we solve for this equation. So for equation, we obtain that alpha AB is equal to minus 7.87 negative 6 squared. Okay, and alpha BC is equal to 31.29. Okay, that's we the negative signs mean that the direction it should be here. Okay, and the positive one, the direction should be here. That's complete this problem. Okay, so for this problem, do you have any question?